Hi students, so now we are going to derive the mirror equation using a concave mirror. Already in our previous video that we have given the rules followed in the concave mirror, right? Now let's move on to the derivation. Right. So as we said that the image obtained is the real image, inverted image and diminished image. It's in the concave mirror, right? Now I'm drawing the concave mirror, the geometric center, that is the pole. This is the principal axis. And this is the center of curvature, right? Even I can draw the center of curvature here. Now, see, this is the point where I have kept the object O dash. So this O dash should come on the top of the object, that is, this is the head and the tail portion, right? Now a ray which is parallel to the object and also parallel to the principal axis incident on the concave mirror. So any ray parallel to the principal axis will always pass through the principal focus. So this is the principal focus. Okay. Now, another ray from this object passes through the center of curvature. So since this ray is perpendicular to the concave surface, so it retraces its path. So these two rays meet at a point here. And then another ray which is incident at the pole of the concave mirror also passes through this point here. So all these three rays, so the angle of incidence is equal to the angle of reflection. Now all these three rays, after reflection, they meet at a point here. So I mark here as I dash. So I draw a perpendicular line with an arrowhead down. So this is I. Here the I dash is the inverted. So I stands for inverted, but real, also diminished. So when you compare the size of the object, here the image obtained is diminished 1, right? So I get an image which is inverted like this. So II dash is the image obtained. Now, we already know that the distance between the principal focus and the pole is F. That is the focal length. And the distance between the center of curvature and the pole is capital R. That is the radius of curvature. And the distance between the pole and the object is the object distance. Always remember, in this object distance O, just remove this, so it becomes U. So this is U, right? And the distance between the pole, here I can the pole and the image is taken as the image distance. So in image, just use another line, so I get a V shape, so which is called as V. And always remember, whenever the distances are measured from pole to this side, that is in the reverse order, all these things, that is V, F, U, they must be in the negative direction. So they are given in minus V, they are given as minus V, minus U, minus F. So always, if the distance is taken opposite to the direction of the ray, then always the sign also changes. So minus V, minus F, minus U. If the distance is taken along the direction of the ray, then these things will be positive, right? So this is the diagram we have drawn, we have completed, right? Now we got to derive an equation. For that, here in this diagram, we got some triangles. Can you see? Now, here I am going to highlight this diagram, this thing, right? And then this thing. So I have a triangle like this. O dash, I dash, and the pole P. So these two triangles are similar triangles. So according to the rules, I am going to use one thing. See, remember, I dash by O dash. So the part of this in this triangle, this thing O dash from this triangle, I dash by O dash, and then in this triangle PI. For this triangle PO. So I am taking this, and always remember the ray which is incident parallel to the principal axis at this point. For example, if I mark this point as A, now this ray is assumed to be incident on the concave mirror very closer to the point P. So if this is assumed to be incident very closer to P, then AP cannot be looking like a curved line, it looks like a straight line. It should be considered as a straight line. So AP is equal to O dash. So remember, AP is equal to O dash. So now this looks like a straight line because this ray as incident on this point A very closer to the point P, right? Now, can you see any other triangle here? Yes, of course. So I dash, then AP here, right? I have highlighted this using the red, that is a pink color. So I dash here F A P. Now again I am following the rule. That is these two triangles are also similar triangles. So we have to apply the similar triangles rule. So I dash in this triangle, and in this triangle AP, and then in this triangle IF by in this triangle PF. Okay. Right, so I dash by AP is equal to IF by PF. Again, we know that AP is equal to O dash. So I dash by O dash is equal to IF by PF. right? Now this is taken as, no, this is the first equation and this is the second equation, right? See, I'll tell you how we derive this using the similar triangles. So when I take this triangle II dash by PI, II dash by PI for this triangle, so this thing and then this thing, and then is equal to OO dash by OP or PO. Okay, now cross multiplying this, I get II dash by OO dash, that is this thing, and then PI by PO. So like this, in this triangle II dash by PI is equal to, according to the rules of similar triangles, so OO dash by PO, and cross multiplying this comes down, this goes up. So I get, even for this triangle also the same thing. Okay, so II dash by IF is equal to AP by PF. Then cross multiplying, I get II dash by AP is equal to IF by PF, right? Now I am going to give some mnemonics if you forgot this. So I dash by OO dash, IIOO, IAO, IAO, right, like that. PIPO, PIPO, like that. PIPO, IAO, PIPO, like that. Then the same thing, IAO, if PIF, like that. If PIF, like that. Okay. So now in these two equations on the left hand side, LHS are same, right? Now let me write this. So comparing the equation 1 and 2, we get PI by PO, that is PIPO is equal to if PIF. Okay. Now in this triangle, I can write this as if plus PIF, that is PF, is equal to PI. Also, if can be written as PI minus PF. So let me substitute the value of if in this equation, right? So let me write this. So PI by PO is equal to, in place of if, PI minus PF by PF. So I get PI by PO, PI by PF minus PF by PF, which is equal to 1. Right? Now, what is PI? PI. So it is a direction taken in reverse to the direction of the ray. PI is nothing but minus V. So here I'm going to write it as PI is equal to minus V. PO is nothing but the object distance minus U. Then PF, reverse direction, so it is minus small f, right? So again I'm wrapping this. So let me substitute the values here. So in place of PI minus V, in place of PO minus U is equal to, in place of PI again minus V, in place of PF minus F, here minus 1. So divide throughout by V on both the sides. So on both the sides divide by V. Okay. So I'll get, if there is a V here, this V will cancel. Minus minus get cancelled. Minus minus get cancelled. So 1 by U will come is equal to Here BB get cancelled, so 1 by F. Here minus 1 by V. If I bring this minus 1 by V here, I get 1 by V plus 1 by U is equal to 1 by F, which is the required mirror equation. I think you must have understood. Thank you.